Hello, welcome back to Cracking the Cryptic, and classic, well, normal Sudoku rules do not apply today. We will be looking at what that means for this bizarre puzzle with no boxes and digits all over the grid in a moment. In the first place, however, I do want to tell you that yesterday we launched the new Patreon reward, which is called Regeneration and involves dividing up the worms in each puzzle into 3 worms each. And like our worm Sudoku that have come out as part of our app suite, those worms are either 6 9x9 puzzles or 9 6x6 puzzles. This Patreon reward is 6 9x9 puzzles that feed into each other and have a worm, basically. So do give it a try. It's proving quite entertaining. There's a couple of tough challenges within the 6 puzzles and some easier ones, so give it a go. That is on Patreon, where also we have difficult crossword videos and connections videos every few days. There will be another one of those up tomorrow as well. So loads going on, as always. Do check that out. It's a great puzzle club. And those worms are part of our apps, which feature all sorts of apps, nothing like today's puzzle, although there is a classic Sudoku app, and that's worth a check out. And of course, there's Fog of War and Those Two Worms by Marty Sinclair. Marty Sinclair, that would be a mashup. Marty Sears and James Sinclair. And they're great fun. Do check them out. Right, let's have a look at what Artham, who's making a debut here, has sent us. Normal Sudoku rules do not apply. However, digits may not repeat in any row or column. So we are placing the digits 1 to 9 in every row and every column. Digits may also not repeat in any 3x3 box centered on a 5. If a 5 is placed on the edge or in a corner, the box around the box that it's in, the 3x3 box, wraps around to opposite sides as needed, like on a torus. So we have one given 5 in a corner, and I can tell you, therefore, that this 5's region is going to be those 9 cells. You see how if you took this grid and the completed form of this grid and copied it and put it to the right and the left and above and below, you would have those cells on the left of this 5, those cells below it, and that. So for the purposes of this puzzle, it's just necessary to know kind of how a torus operates, and that these 9 pink cells will all be different because they will act like a box. Now I imagine we can have overlapping boxes in this puzzle. In fact, I think we must do. I'll discuss that in a moment. But that's the rule. It's quite strange. We get a lot of given digits, and it still may feel like very few in due course. Give the puzzle a try on the first link under the in the description field under the video. I'm going to start now. Let's get cracking. And I'm actually immediately going to restore that colouring, because this is one of the regions, and what I'm going to try and do in this puzzle is colour the regions. So that is one. This is another one, because we've got another 5 here, and that is centering this, what I've now made a grey region. Oh, this grey region needs a 7 in it, and by Sudoku, 7 is ruled out of those cells, so I can put a 7 in. Then the other digits in the region are a 4-6 pair, which must be there because of this 4 and 6, and a 1-9 pair, which are resolved because of the 9 we get. So I've nearly finished one of the regions. Okay, this is working differently, isn't it? I mean, I'm looking at this column going, where does 9 go? But it's such an odd question, because it could still be here. It doesn't have to be in the pink box. The pink, very disjointed box. So maybe it's going to be hard to get moving unless we can establish regions and where 5 is. And there must be cells in this puzzle that aren't part of any regions. Now, how do I know that? Because if every cell was part of a region, the regions would tessellate the grid exactly. They can't do that because you can't get two 5s in the same row or column, and therefore you can't abut them up exactly. So there will always be, unless there is a toric 9x9 tessellating pattern. Well, there can't be. These two cells, well, these two cells could be in a region if we found a 5 somewhere that would accommodate them, but then there'll be overlaps, and as soon as there are overlaps, clearly all the other, there are 81 cells in the puzzle. If one cell is doing duty in 2 boxes, then there must be a cell somewhere that doesn't get into a box just by maths. Oh look, just by Sudoku, I can read this row and go, we need a 3 and a 5, and that 3 is telling us which way round they are. So enough theorizing. Oh right, 5. 5 is the center of a new box. Let's make it orange. So we've got 4, 5, 6. The 7 in the box is in one of these cells. The 9 in the box is in one of these. Oh, is that? Can I not do much more than that? 5, 4, 7, 6. This digit is 1, 2, or 8, and that must appear in the bottom row of this new orange box. I'm irritated that there isn't a little bit more information. I mean, it's just the nature of the beast. It's not that I've been cheated. Whoa, hang on. Now, I'm quite good, people say, at spotting naked singles in normal classic Sudoku. I think I've just spotted one in this weird puzzle. Because although we don't have boxes, except where we've found them, we do have horizontal and vertical digits. So this cell, let's just make it red so you can keep your eye on it, C's 2, 7, 3, 6, 9, 8, 1, and 4. And that is the digit we need. That is a 5. So let's paint a red box around that. 5 is always the center of a box. So there is overlap now. We've definitely found some. 5, 6, 7, 3 are placed. We need an 8 in the box, either there or there. I'm scared of using the normal Snyder notation to say 8 is in one of the positions within this box. We need a 9 in the box, and that's in one of those two. So that is now not a 9. This digit is a naked single because 7 and 6 are in its box. It sees 8, 1, 5, 4 in the column, 3, 9 in the row. That now has to be a 2. 2, 3, 5, 6, 7. This one is now a 1. That's all it can be. It sees 4, 8, 9 in the row. And we've got to fit a 4. We can use the fact that this orange box can't have another 4 in it to fit the 4 in there. Then we can place the 8 and then the 9. This is a strange puzzle, isn't it? Right. The rest of this row is a 1, 2, 3 triple. The rest of this row is a 1, 8 pair. What about this row? We've got 5, 6, and 7 to place. So making allowance for digits above and below, we can do that. This column, we've got 3, 6, and 7. This can't be a 6 because we've had a 6 in orange. In fact, let's have a look at orange. 9, 8, 4, 5, 6. 1, 2, 3, 7 to put in these cells. It's not that helpful. Such a weird puzzle. Okay, pink. The pink one round the corners here needs a 9 in, and it can't have it in this column, and it can't have it in this column. So one of these is a 9. I am prepared to pencil mark within boxes. That's what I'm doing. 5, 9. Are there any other digits that are desperately trying to find their location? I suppose these 3 that I've got highlighted are from 1, 2, 3, 6, 9. That's not actually very useful. Right, we found some 5s. Maybe we need to find other 5s, or at least possible locations for 5s. One of these two is a 5. Right, we know it's not here, because that would have a region which would have 2 9s in it. So that is the 5 in row 3. And we're going to give this region a good old color as well. There's some overlap with the red, that's fine. We've also only got 2 4 7 to place. That digit must be a 2, and these are a 4 7 pair. That's not a 2 by Sudoku now. What about this row? 3 5 6 8 9 to place. Okay, the pink cells in this row can't be 5. So we're selecting from 3 6 8 9 because 5's already appeared in pink. 2 of them can't be 9s, those 2. Okay, my profitability earlier was in finding 5s, and in this row there is a 5 in one of those 2 cells. Now that's quite interesting. So I don't know exactly where it is, but I do know that it'll be the center of a box that will include those 6 cells. So we can't include those as well, or we'd be repeating 8 and 1 in the box, so we've got to have those in, and this is the 5, centering the green box. Now this can't be 8. In fact, we've had 1 4 5 8 in this. We need a 7 in it, that has to be here. A 2, that has to be here according to the pencil marking, I think that's right. And these other 3 digits are 3, 6, and 9 in some order. So we found the 5s in the first 6 rows, it feels like. We've got 3 others to find, 1 somewhere here. Ooh, 1 in one of these 2 cells, right. That's interesting. So for column 8, the 5 has to be in one of those 2. And that is going to center a region which includes these cells. And either those 3 or those 3. Now that's a little harder to make a ruling on than that light green one. So that's one of them. There isn't also a 5 in the final column in one of these 3 cells. Not there. Well, yeah, it can't be obviously next to the other 5. I don't know. It could be there and include these and those. There's no break on that. It could easily be in row, that could be a region is what I'm trying to say. What about this being a region? This would be very hard to... Okay, that is not a region because it would have another 5 in it. So there is not a 5 here. So there's a 5. Oh, yeah, okay. I mean, I could have worked that out from the fact that there was a 5 there, so there couldn't be a 5 here. Right. I mean, it works either way around for either region. But there is a 5 in one of those 2 cells. There is one in one of those 2. And which was the other column? This column. There is a 5 in one of those 3. And now I know I'm not marking within a box like I said I would, but 5's a special case. One of these 2 is the 9 in the pink region. What does that mean? I haven't got a clue. 2, 9. It's a little difficult to know quite what to do. I mean, there's plenty of digits marked in the puzzle. These are from 1, 3, 6, 9. They're the only candidates. That one can't be 9. So let's think about pink. We've got 5, 2, digits from 1, 3, 6, 8, 9. We still need to get a 4 and a 7 into pink somewhere. Now that could be either, whichever it was would decide there was a 6 in one of those. Alternatively, these 2, well, this can't be a 7, can it, in the row? So what can this digit be? It can't be 5, 2, 7, 8, 9, or 3. So it is 1, 4, or 6. And the 7, right, the 7 in pink is going to have to be in one of these 2 cells. And that means this digit is not a 7. This could be a very slow way of eking out information. Right, these ones are 1, 2, 4, and 6. That one can't be a 4. I do definitely need to keep thinking about the regions. Maybe I need to think about this one. Oh, this has got interesting combined with those. Yeah, right. The simple way to look at that is where are 5 and 8 in this row? They can't appear in orange. So they must be in that cell and that cell. That's a 5, 8 pair. Now, one of those is a 5. Knowledge bomb. If it was here, it would be in a region centered around it, containing 5, 9, 2, 4, 1, 6, 3, 7, and that would be 8. Okay, well that's possible. If this was 5, the region would be here, and the 3 cells covered in row 8 would be 2, 6, and 8. Okay, I'm going to use that. I'm going to say that if that was the case, this couldn't be a 6. There's either a 5 here or here. If that's a 5, there's a 6 in one of those cells, and this isn't a 6. If that's a 5, this pair can't be 2 or 4 and must be a 1, 6 pair, and that's in the region and can't be a 6. So that is never a 6. So this is now a 3, 7 pair, and this is a 6. And that means that 6 doesn't appear in pink in these cells. Is that interesting? 6 must now appear in pink in one of those 4. It's less interesting than I was hoping, I'll admit. Ah, goodness. This is a peculiar way to have to think about Sudoku suddenly. Right, which one I don't think this is the 5. So what would happen here? We'd have 9, 2, 4, 1, 6, 3, 7, and that would be 8. If this was 5, that would be 8. Otherwise, this is 8. So one of those two is always 8. Now this digit sees that 8, 2, 7, 4, 1, and 6. This is 3, 5, or 9. Can it be 5? That's a good question. If this was 5, right, this would be the region centered around it with 6, 7, 8, 3, 9. No, it couldn't. And the simple reason is because you couldn't get 1, 2, and 4 into this region. If this was a region centered around 5, where would you put 1, 2, and 4? Only in column 3. They can't go in column 4 or 5, and they can't all go in column 3. So this is not a 5. This is not allowed to be the center of a region. And now the only place we've got a sort of 5 X-wing, 5 is in one of those cells in column 9, one of those cells in column 4. 5 is not here, and 5 now is here. The dark green region includes these cells. Right, now, what do we learn? So it can't have another 5 in, and that is a 5, and now this is a 5, and now we've got all our regions done. Let's make that light blue, and this one, oh, it's centered over there. What haven't we had? Yellow. There we go. That's a good contrasting color. Right, that 5 says this digit is an 8. And now this blue region has a 3, 7 pair, so that's 9. And it's had a 6. So this is a 1, 2, 4 triple, and that's 6, and that's 4. And this light blue region is sort of done now. Now, that digit has to appear somewhere in orange, and it's got to be there. So that's not a 3. And this is therefore where 3 is in this row, in a cell that will never get into a region. Now, I haven't thought about dark green as a region yet because I haven't got much pencil marking in that. Let's just keep doing what I am doing at the moment. 6 in this row does not sit there or there because of 6s. It must be there. And that means there are other things in that column that aren't a 6. So let's go back to the pink region. Well, no, let's not ask about 6 in the pink region. Yes. No, I already worked out ages ago that none of those is a 6. So let's not. Let's do yellow. 1, 9, 7, 3, 4, 5. The others are 2, 6, and 8 in the yellow cells. There they are. Now, they're going to knock 2 out of that cell. These are 1, 3, 4, 5, 7, 9 in some order. We know where the 5 is. That's annoying. 2, 9, 3, 7, 4, 5. That can't be 2. We're looking to place 1, 6, and 8 in this column. Okay, I'm going to have a look at this column because if I can get anything into the dark green cells, that could be very helpful. 5 and 6 in the column. Oh, it's useless, isn't it? These include 3 and 7, one of them there. Oh, which shape am I not considering enough? Maybe it's pink. Maybe it's this original pink. Okay. Let's consider where 9 is in this shape, because it isn't here. And it's not here or here. Pencil mark wise, this has to be 9. It's the only 9 that can go in pink. So that's now a 3, 6 pair. Oh, that was blindingly obvious, wasn't it? Oh well, sorry. 8 is either there or there, and therefore is in pink already. Somewhere in row 2, there is an 8 in pink. Therefore, these cells in row 9 don't have an 8 in pink, and the 8 in row 9 has to be here. And that is in green, dark green. So this becomes a 6, that becomes a 2. Now we've got 6 in dark green, that's a 1, this is a 4. The other digits in dark green are 3, 7, and 9. That's 3 or 7 in the corner. This could be any of them, and this one is 3 or 9. Now, in the pink, we got a 4 there, along with 5, 2, 9. We need 6 and 8 to appear in this row, so that's a 6, 8 pair, and that becomes a 3. So we've had 5, 6, 8, 2, 9, 4 up here. These are a 3, 1, 7 triple. That is 3 or 7, and that is 1. This can't be 1. We've got 2 and 4 to place in the bottom row. This can't be 1 or 9 anymore. This is a 3. That sorts out 7, 3. Makes this digit 9, and that's in green. 9, 6, 2, 8, 5, 1, 4, 3, and 7. That 7 is in pink, makes this a 3 in the corner of the grid. That's 3 in the corner, but not in the corner of its box. That's so strange, isn't it? In this box, we've had 7, 3, 1, 5, 2, 4, 9, and we've got a 6, 8 pair to resolve. That 6, 8 pair is helping form a 6, 8 pair in column 1. So that digit is a 7, that's 6. That sorts out the 6, 8 pair. And that brings almost all the puzzle to fruition. That 2 looks at this cell, 1 there, 2 there. This 8 that we got earlier, just as the 1 in dark green has resolved that pair. This 4, 7 pair is not officially resolved, but orange needs a 1, 7 pair to complete it, and that's going to resolve the 7, 4 pair. This is a 9 to complete the row. Then I've got 2 and 4 to complete the column. I know which way around they go thanks to this 2. And then finally, 1 triple left in light blue, 4, 1, and this must be the solution. So puzzle's called Give Me 5, and it's a very entertaining idea by Artham. little bit mind-blowing in a way, but I like how these, there were some overlaps and some, not very many missing digits in the end. Digits missing from all cells were 4, 7, 8, 9, 11, 13 of them. And there must, I think, therefore be exactly 13 overlap cells. Just checking my maths here. Right, 1, 2, 3, 4, 8, 9, 10, 11, 12, 13. Exactly. No cell overlapping in more than 2 boxes, I don't think. Or else that maths wouldn't have worked. But that's an intriguing puzzle. Very unusual. Toric, but very well-centered. Eccentric, could we call that? Because the centers aren't exactly where you'd expect to find them. I don't know. Anyway, thank you so much for watching us on the channel. And we really wish that you will come back and watch us again tomorrow for more Sudoku fun. See you then, and bye for now.